Hi and welcome to Topic Busters from onmaths. Today we're looking at compound measures, so hopefully we can speed through a few questions so you feel under less pressure on the exams. Enjoy! Hi and welcome to Topic Busters from onmaths. So today we are looking at compound measures. Now compound measures used to be quite a small area of maths. On foundation it mainly was speed, and on higher it was a little bit of density occasionally. It seems that they've changed that. They've created a fifth strand, so number, algebra, shape, size and measure, data, and now ratio and proportion. Now we looked at ratios last time. This is more of a proportion one, but it's definitely as part of that strand. Now, because that strand has a big percentage of the paper, expect compound measures to come up. So the things I cover in this video, which the main three are speed, density, and pressure, although they actually can come up with any compound measure they want. So for example, fuel consumption or rate of pay or anything that they want, and we'll cover that towards the end of the video. So the way I describe this is in form of a triangle. Some teachers do not like the triangle, some teachers just use the triangles. I find at this stage, coming up to your exam, if you don't know all the formulas off by heart, the triangles just are a really quick way of remembering them. And you have to remember the three, the speed, density and pressure formulas. Okay, so hopefully you enjoy this video. Let's get started. So we're asked to convert these into hours. The first one's 30 minutes. Now, a common mistake for these questions is students think there are 0.3 hours for 30 minutes. Now, this is a common misconception because this is a student thinking metrically, like centimetres to metres, that there are 100 minutes in an hour. But we all know that there's 60 minutes in an hour. So if I get rid of that. Now, you know 30 minutes is half the turn of a clock, right? And you know a full turn of a clock is an hour. So this is just half an hour. Now you could write that as 0.5 hours. Okay, so the next one's 75 minutes. Now this time there is more than an hour because there's 60 minutes an hour. So and what I'm going to do is I'm going to do 75 and I'm going to take away 60 because I know that that's going to be 1 hour and that leaves 15 minutes. So we've got 1 hour for that 60 we took away plus 15 minutes. Now it doesn't want hours and minutes, it just wants hour. Again, a student might think, oh okay, well that's going to be 1.15. But again, this is assuming that there are 100 minutes in an hour. If you think about it, 15 minutes, what is that in hours? Well, that's a quarter of an hour. So that's going to be 1.25. 0.25 is a quarter, so 1 hour and a quarter is 1.25 hours. So just remember, 30 minutes is half an hour, 15 minutes is a quarter of an hour. Now I could write that as 1 and a quarter hours. Okay, this last one, 3 minutes. Well, this isn't a common one that we say, oh, I'll meet you in a fraction of an hour. Okay, 3 minutes doesn't really have a fraction like 30 minutes and 15 minutes does. Just think about, well, how many minutes are there in an hour? Well, there's 60. So 3 minutes is going to be 3 over 60 hours. Now, you could write this as a decimal by using your calculator, doing 3 divided by 60, and then you can have it as a decimal. I can actually cancel that down if I look at it. You can divide top and bottom by 3, so that becomes 1 over 20, so 1/20th of an hour. And, well, that's going to be 0.05. Okay, have a go. So this first one, 45 minutes, we say 3/4 of an hour. Okay, if you think about it, a quarter of an hour is 15 and 45 is 3 lots of 15. So that's just going to be 3/4 of an hour. Or you can write 0.75 hours. Okay, so the next one, 135 minutes. So you first of all got to think, how many 60s can I take away from 135? So if I do 135, take away 60. So I'm going to start by taking away 60 from 135, and that gives me 75. And then I'm going to do 75, take away another 60, that leaves me with 15. So I've taken away 2 lots of 60 from 135, so we know we're going to have 2 hours in there. And how many left over? Well, 15 minutes. But again, that's not in hours, it's in hours and minutes. So that's going to be 2¼ hours. Or 2.25 hours. Okay, this last one, 5 minutes. Well, again, how many minutes are there in an hour? Well, there's 60. So 5 minutes would be 5/60 of an hour. Again, I can divide top and bottom by 5 to get 1/12 hours. And then on your calculator you could do 1 divided by 12 to work it out as a decimal, and that's going to be 0.083 recurring hours. It's probably easier as a fraction. Okay, so the most popular compound measure is speed. Now, compound measures mean that you need 2 other measures to make this compound measure. Now, if you think about speed, there's no way of measuring speed without measuring time and distance. So all those speed cameras, speed guns, anything to do with speed is measuring the amount of distance covered over a set amount of time. If you ever have seen someone be flashed on the motorway, you'll notice there's 2 flashes. The reason there's 2 flashes is that they take 2 pictures of the car at 2 different points. They know the distance between the markings on the road, and they measure how much distance the car's travelled between those in the set amount of time, and they fix the amount of time between the flashes. So there's a bit of highway code information you probably didn't need to know. However, that is what speed is. So the most important thing we remember, and you must remember this, is this triangle. And some teachers hate this triangle, but I like it. Now, with this triangle, it doesn't matter whether you put speed on the left or speed on the right. It doesn't matter whether you put time on the left or right. But what does matter is that distance goes at the top. Now, the way you use this triangle is you cover up the one you're looking for, and it shows you how to work out the other 2. So, for instance, if I covered up speed, it would tell me to do distance divided by time. If I covered up distance, it would tell me to do speed times time, and if I covered up time, then it would show me to do distance divided by speed. So this first question says that we've got a speed of 35 miles per hour, and that's signified by mph. And whenever you see mph, it's always miles per hour, not meters per hour. And it says that the time is 120 minutes. Now, there's already a problem there because the time is in minutes and yet the speed is in miles per hour. So I could convert speed into miles per minute, but that's really, really complicated, so I'm not going to do that. I'm just going to change time into hours. So the first thing to do is just change time into hours. 120 minutes is 2 hours. Okay. Now it's looking for distance, so I look at the triangle. I'm looking for distance, so I cover that up with my thumb, which I can't show on this, but imagine I'm covering up the distance with my thumb, and it's saying do speed times time. So let's say distance equals the speed, which is 35 miles per hour, times the time, which is the 2 hours, and that's going to be 70. Now, units are given to us in the speed. The speed says miles per hour, so it's going to be in miles. 70 miles. Now this would be normally in the context of a distance time graph or a context of a worded question. I've taken the numbers out of what would be a worded question, so always look for speed, time, distance. You'll always be given two of them or a way of finding out two of them. Okay, this next one is similar question, but now it's given us distance and time and asks us for speed. So looking at the diagram, I'm looking for speed, that's the bottom left one, so I'm covering that up. It says distance divided by time. So speed, it's not a bad idea to just write out the formula. So speed equals distance divided by time. So distance is 60 meters and time is 12 seconds. So how many 12s are there in 60? There are 5. And the units will be meters per second. Now you might be wondering, why is it not MPS? Well, the MPH only works for miles per hour, and it's just a funny one. Most of the units are something slash something, but because miles is imperial, it just has a special symbol, MPH, instead of M/H, which might look like meters per hour. Okay, so that's that done. Now this last question is quite a complicated one, and I've tried my best to show the information from a long worded question. So we're travelling from A to B, and it's taking 2 hours, and we're travelling 60 kilometers. Then we're travelling from B to C, it's taking 3 hours, and we're travelling at 40 kilometers per hour. Then it's asking us to work out the average speed of A to C. So the first thing to realise is that average speed, and we can use our triangle for this. This time though, it's total distance. I'm going to run out of space, so total distance over total time. So we don't have the total distance, but we do have the total time. So let's write that in somewhere. So the total time from A to C, we've got 2 hours from A to B, and then we've got 3 hours from B to C. So that's going to be 5 hours. Now, we don't have the total distance. We've got the distance from A to B, but we don't have the distance from B to C. So let's write it up here. So we're going from B to C. So the distance is the speed, which is 40. Oh, I've gone to a different colour for some reason. Speed, which is 40, times the time, which is 3. So 4 times 3 is 12, so that's going to be 120. And we're doing kilometres, aren't we? So now I can work out the total distance. Which is going to be the 60 kilometres from A to B plus the 120 we've just calculated. That's going to be 180. Okay, so we've got 180, which is the distance, divided by the total time, which is 5. Okay, so how many 5s are there in 100? There are 20. How many 5s are there in 80? How many 5s are there in 50? There's 10, so that's going to be 30 so far. And how many remaining 30? There's 6. Now we could use a calculator if this is in the calculator paper, but that's going to be 36. You could also use the bus stop method for that. So if I do it up here, 580, 5s into 1 don't go, 5s into 18 go 3, carry 3, 5s into 30 go 6. So that's how you do it with the bus stop. Now the units of the speed are in kilometers per hour. I'm running out of space here, so kilometers per hour. Okay, have a go. Okay, so for this first one we need to convert the time first. So 180 minutes, well that's 3 lots of 60, so that's going to be 3 hours. and then distance is just going to be 75 times 3, so 75 miles per hour times the 3 hours. Now times 75 by 2, you get 150, and then add another lot of 75, you get 225. So that's 225 miles. Okay, so for the next one, we know that speed equals distance over time. The distance is 55, the time is 11, so that's going to be 5 meters per second. Okay, and the last one, we're going to first of all work out the distance from B to C. So, blue again. B to C distance. And that's going to be 3 times 50, which is going to be 150. What's it in kilometers? So total distance is 100 kilometers from A to B plus the 150 from B to C, so that's going to be 250 kilometers. Total time is going to be the 2 hours plus 3 hours, which is 5 hours. So average speed is going to be the total distance, which is 250, over the total time, which is 5. 25 divided by 5 is 5, and so that's going to be 50, and that's going to be in kilometers per hour. Okay, so now we move away from speed and onto other compound measures. Now, density is another compound measure, and it works in a very, very similar way to speed. Density can't be measured directly. To measure density, like speed, you need 2 other units. Now, instead of distance and time, density requires volume and mass. The triangle for density is very similar to speed, but density at the bottom left, just like speed was, but this time density is mass over volume. So the triangle looks like this. So for this first question, it says the volume's 5 and the mass is 2000. Work out the density. So density, and that equals mass over volume. So the mass is 2000. The volume is 5. So 5's into 2000. Well, I know there are 4 5's in 20. So in 2000 there's going to be 400 5's. So 4 times 5 is 20, and that would make 2000. Good. So density is just the units of mass, which is kilograms, slash the units of the volume, which is meters cubed. Okay, to work out the next one. Now, it's quite common for the question not to give you volume directly. You might need to work out the volume. So we need to work out the volume first. Now, for the volume for this shape, or what shape is it? Well, it's a triangular base prism. So you need to work out the area of cross-section, so the area of the triangle, times the length. So the area of the triangle is half times base, which is 4, times height, which is 6. So I'll put that in brackets. And then we'll times that by the length. Now the length is just 10. The length is how 3D the shape is, how long the prism is. Okay, so I can halve the 4 to make 2, and then 2 times 6, which is 12. Or I could have done 4 times 6, which is 24, and then halved it, which is also 12, times 10. Now I'll just do this on the same line to save space. It's going to be 120. Now we've got to look at the units. It's in centimetres cubed, because all the units are in centimetres. Now be careful, one of them might be in metres and you might need to convert it. Okay, now we know we need centimetres cubed because the density is in grams per centimetres cubed. So we need to work out the mass, and it says the mass is density times volume on the triangle. So our density is 0.5, and we're going to times that by the volume, which is 120. Now 0.5 is just half, so what's half of 120? It's going to be 60. Now we've got to work out the units for mass. Well, the units for mass are either kilograms or grams, probably. So looking at the units for density, it's grams per centimetres cubed, so therefore that tells me that it's going to be in grams. Now this last question is not to do with density, it's a third compound measure, okay, and this third compound measure is called pressure. Now pressure, just like density and speed, you can't measure pressure directly. To be able to measure pressure, you need to work out what the force is and over what area. So we're going to do this triangle now. So this triangle is pressure. Okay, and pressure is a compound measure like density and speed. Force goes at the top and the area goes at the bottom. Okay, now there are 3 triangles you need to remember, okay, and this is the third triangle. There's technically a fourth which we'll cover in the next video, but these are the main 3. Okay, so it tells us that we need area, so we need to work out the area of that. So the area is just 3 times 2, which is purple for some reason now, 6 meters squared. Be careful not to put cubed because it's an area, so it's going to be meters squared. Okay, and so pressure is going to be force, which is 120, over area. Now I know 12 divided by 6 is 2, so it's going to be 20. Now let's think about the units. The units for speed were miles per hour, or meters per second, or kilometers per hour. The units for density were grams per centimeters cubed, centimeters cubed, or kilograms per meters cubed. So have a think, well, what's the units for force? Newtons. What's the units for area? Meters squared. So it's just going to be 20 newtons per, I nearly wrote centimeters, but our units are in meters, per meters squared. Okay, have a go. Okay, so for this first one, to work out the density, you've got to do the mass, which is 210, over the volume, which is 7. Now I know 21 divided by 7 is 3, so that's going to be 30. Let's get the units. Now the mass is in kilograms, and the units are in meters cubed. So it's kilograms per meters cubed. Okay, this next one, go work out the volume first. So the volume is the area of triangle times the length. So the area of triangle is half times base times height. Which is half times the base, which is 5, times the height, which is 6, and the length is 10. So 5 times 6 is 30, half of that is 15. So that's going to be 150 centimeters cubed, and so therefore the mass is going to be the density, which is 0.1, times the volume, which is 150. Now 0.1 is a tenth, so to find a tenth of 150 you just divide it by 10. So that's going to be 15. Now we're going to do the units, so the mass will be in grams, because our units are in centimeters cubed, and for the volume, and the density is grams per centimeters cubed, so it's going to be in grams. Okay, last one. Got to work out the area first. And so that's going to be 3 times 4. And we're assuming that the force is exerted across the whole of this area. So, and that will probably be stated in the question. So it's going to be 12 meters squared. And so therefore the pressure, using our triangle, says force over area. So it's going to be 60 over 12, which is 5 newtons per meters squared. Okay, just an additional note, there are many other triangles which we haven't covered in this video. So rate is quite a big one. Now rate is just, it could be anything at the top, so it could be length, height, so it could just be any kind of unit at the top, but the rate will be at the bottom left because that's our compound measure. The unit given, whether it's a height or a pay or anything, is at the top, and then whenever it's a rate, it's always going to be time at the bottom. There could also be hundreds of thousands, okay, maybe not that much, but loads of other triangles you might be asked to use. Okay, so the important thing is look at the unit of whatever it's about. So rate of fuel consumption I've seen before. So the unit is given as kilometers per litre. So consumption is at the bottom, that's our compound measure. Kilometers, well, that's distance. And litres, well, that's obviously going to be capacity. So just be prepared to use these triangles over a whole wide range of questions. And if you're given a unit like this, the one on the left hand side, this one here, will always go at the top, and the one at the right hand side will always go at the bottom. And then whichever one that's describing, in this case, fuel consumption, that's just going to go at the bottom left. Okay, the most important one that you place is the top one, because the other two at the bottom, it doesn't matter which way around they are. Thank you very much for watching this video. I hope you found it useful. If you want to try more questions, please go to our website onmaths.com, where there's a whole myriad of questions to practice on this topic and all the other topics. Thank you very much for watching.